Okay, so now in this lecture, I'm just going to tell you a little bit about the hypothesis testing error. So until now, we have already discussed the criminal trials, that in criminal trial, what will be the type 1 error and what will be the type 2 error. So here's some shocking news for you that nobody perfect. Yes, if as I already mentioned, the production. So every organization want to produce some goods, quality goods, because if they produce in some defective items, then what the customer will return that item, and at the end it will be totally converted into a loss for the organization. So every organization, every person, if they provide in services or if they produce in something, they try their level best to produce some good product. So no one want to produce some bad product, but we know that only God is the perfect. Okay, in production, maybe your quality level is very high, maybe you keeping Six Sigma, but maybe something happened, maybe some defective products you produce. Then in that case, what you will do, even with the lots of evidence, you can still make the wrong decision. Sometimes we have a lot of evidences, but we prepare a specific lot, we accept a specific lot, we buy some product, we buy a car because the brand of that car, because the brand of that mobile phone is very good, they have some history, but still there is a chance that maybe it will not perform well. So now in this one, I just want to discuss in this lecture some errors. When you will be going to make an error, when we perform hypothesis test, we can make mistake in two ways. The null hypothesis is true, but we mistakenly reject it. So just like in the jury example, the client is innocent, but the jury say that the client is not innocent, but he is guilty. Or maybe the client is guilty, but the jury will say, according to the evidences, they will say that the client is innocent. So there are two types of error. I don't want to go into the detail because in my previous lectures I have already discussed this type 1 error and type 2 error. So while doing hypothesis testing or sampling testing, we can make these two types of errors. Now, which type of error is more serious? So both type of errors are serious, but now which one will be the most serious one? So it depends on the situation at hand. It depends on the experiment which you want to conduct. In other words, the gravity of the error is context dependent. It depends on the environment. It depends on the analysis. Here is an illustration of the four situation in a hypothesis test. So it's not true, but my decision, we will reject it. So when you reject a true, let's suppose you reject a true production, a good quality production, you say that this production is not good. So this is called type 1 error. If you reject it on the basis of the false statement, on the basis of defective element, so it's okay, it's a nice decision. But if you fail to reject it, but the hypothesis, but the products are good, so it's okay, fail to reject it, it means you will accept it. But if the product is defective, the person is guilty, and you fail to consider that person guilty, it means you consider that person innocent, so this is called type 2 error. So how often will a type 1 error occur? Now this is the question, and you need to solve that question, and you need to find the probability of this question. Since a type 1 error is rejecting a true null hypothesis, the probability of type 1 error is our alpha level. So normally we use this alpha, and which denote the level of significance, which denote that you reject a good quality product. The product of the quality is good. The quality of that product is good, but you reject it. When H0 is false and we reject it, we have done the right thing. In the other scenario, if this is false, if this is guilty, and we consider that it is guilty, so it's good. A test ability to detect a false hypothesis is called the power of test. So now we need to conduct a power test. That the analysis, the acceptance and rejection decision which we already conducted, is it right or is it wrong? And how much is the possibility of it? So when H0 is false and we fail to reject it, we have made a type 2 error. We assign the letter beta to the probability of this mistake. It's harder to assess the value of beta because we don't know what the value of the parameter really is. There is no single value for beta. We can think of a whole collection of beta on one for each and correct a parameter value. So in the quality management, we call alpha as a producer risk and we call beta as a consumer risk. So what is producer risk and what is consumer risk? So producer risk is, as I already mentioned, that if a producer producing good product, so their aim is to produce 100% quality good product, but maybe during the production some random processing error occur and there are some defective lot also occur in that production. So now if an inspector select a sample from that product, if in the selection of that sample, if he select some defective product and if he check it and then on the basis of that defective product, if the inspector reject the whole lot, so it's mean it's a huge loss for whom? For the producer. So the producer try their level best to keep this value a very minor one, because if this value increase, it's mean there is too much risk, there are too much defective part in the whole lot. So when the value of alpha is going up, it's mean there is a high chance that the inspector will find some defective parts from the in the sample, and on the basis of that they will reject the good lot. So if they reject the good lot on the basis of those defective items found in the sample, it's called type 1 error. Beta, which is also called consumer. So basically if a firm producing 50-50 mean if they're producing 100 units, in those 100 units, if they produce 50 defective and 50 goods, if an inspector randomly select some parts, some sample size, and fortunately in that sample, if they found that they are good parts, so on the basis of good parts, even though in the real sense that lot should be rejected because there are 50-50 chance, there is too much risk involved, there is too much mean defective parts involved, so they need to reject this. But on the basis of that sample, they will accept a rejected lot. So this is a very huge risk for the producer, for the consumer, because consumer will buy that lot and at the end he/she will know that what that I did, because if there are 100 units, so 50 units will be defective. So one way to focus our attention on a particular beta, which is also called the consumer risk, is to think about the effect size. Okay, how big a difference would matter? We could reduce beta for all alternative parameter values by increasing alpha. So when we increase alpha, okay, when we increase alpha, this would reduce beta but increase the chance of type 1 error. Okay, because when you increase the alpha, what does it mean? It's mean the level of significance will be increased. It's mean in your production, the defective proportion will be going up. Okay, this would reduce beta because alpha and beta are working in negative direction, in the opposite direction. When one going up, the other is going down. This would reduce beta but increase the chance of type 1 error. So the chance of type 2 error will be decreased, but the chance of type 1 error will be increased. Why? Because maybe the inspector takes some defective product and on the basis of that, maybe they will reject your whole lot. So this tension between type 1 and type 2 error is inevitable. The only way to reduce both type of error is to collect more data. Otherwise, we just wind up trading off one kind of error against the other. So in order to further expand this, sometimes the inspector conduct not only single sampling, they conduct double sampling, triple sampling or multi-sampling. So when they conduct double, triple sampling, these sampling techniques further reduce the probability of error, further reduce the probability of risk. So at this way, they will remove the riskier part from the analysis, and on the basis of this, they divide the whole scenario. So hypothesis testing, as I already mentioned, that null hypothesis normally it contains the sign of equality. So null hypothesis means, for example, if H naught is the mean is equal to 120, so alternative will be it's not equal to 120. So you can see it's always include the sign of equality. Or if H naught is mean is greater than or equal to 120, the alternative will be that mean is less than 120. So once again it's contain the sign of equality. If H naught mean is less than or equal to 120, so H1 will be mean is greater than 120. So you can see the null hypothesis always include the sign of equality, and the opposite of this one will be, so this is the less than. the opposite of this is not equal to, the opposite of this one will be less than, and the opposite of this one will be greater than. So we will construct, and on the basis of the alternative, because on the alternative basis we will confirm that the tail of the test is two tail, or it's mean that the risk is split in two parts, or it's in the right tail or it's in the left tail. So for example, if it is two tail, then we will sketch it that, for example, if it is a two tail test, then we will split this, because we are not sure that if I ask you that how many unit of let's suppose a specific pen, or how many rupees, or how many unit of dollar in my pocket. So mean you can say that you have 120, okay, or you can say that if I say that I have 120 rupees in my pocket, you will say no, you have not 120. So maybe it will be greater, or maybe it will be less than this. So that is why we will divide this in two tails. Right tail, normally we represent right tail at this way. This is right tail. For example, the opposite of this will be less than or equal to. If I say that in my pocket there are 10 or less than 10 rupees, so the opposite of this will be greater than. You say that it will be more than 10. So more than 10 will be occur at this left tail test. So left tail test will be represented as this one. Okay, this is left tail test. So at this way you will interpret, you will design the experiment for the alternative hypothesis, and you will decide on the basis of alternative hypothesis that is it a right tail test or left tail test. Thank you.